So hello friends, welcome back to another video on stick diagrams. So in the part 1 we have seen the stick diagram for an CMOS inverter. In this lecture we will try to draw the stick diagrams for a NAND gate, NOR gate and a Boolean function. Okay, so just to recap, in the first lecture we have already seen the stick diagram for CMOS inverter, right? So in this lecture we will try to draw the stick diagram for NAND gate. Okay, so just we will see the color codes in the stick diagram are metal is blue and N diffusion is green, P diffusion is brown and polysilicon is red. Okay, these are the four basic color codes we have used, right? So now we will try to draw the stick diagram for a NAND gate. Okay, the circuit diagram for the NAND gate is, we have already seen PMOS transistors are connected in parallel and NMOS transistors are connected in series. Okay, this we have already explained in the previous lectures, right? So A, B, I will take the V out from here and this is my VDD and this is ground, right? Now I will try to draw the stick diagram for this NAND gate. Okay, so what we will do, we will start with metal. Okay, this is my VDD and VSS. Okay, now first I need to I need to have two PMOS transistors here which are in parallel. So for PMOS transistors, what we will do, we will take the brown here. Okay, so two PMOS transistors in parallel, brown, red crossing brown is a PMOS, right? Red crossing brown is a PMOS 1 and this is the PMOS 2. Similarly I have a green here. Okay, and red crossing green, you see here in series, this is NMOS transistors. So before drawing this I can have a demarcation line here. Okay, now I have realized two transistors of PMOS and two transistors of NMOS. Now what is left over, I need to establish the electrical contacts. You see here, this is an electrical contact, this is an electrical contact and here also it is an electrical contact. Okay, now we will try to have the inputs and all, right? So you see, what I will do is I will take the blue, I will take the metal. Okay, let us say this is A input, B input and A and B. Okay, now I will try to connect these things. So what I will do is, instead of using more polysilicon, okay, which is costlier, what I will do is I will use a simple metal. Okay, so because I am using a metal, I need to establish a contact here. Okay, and I will give, this is metal to metal and A input here. Okay, similarly now you see here, the other thing is, again I will connect the B and then we need to connect the transistors as well. Okay, fine, no problem. Now what we will do, we will take the metal again. Okay, and you will connect like this both the transistors. Okay, and you see here I need to establish an electrical contact here, right? And I will take a blue and blue is connected to green. Okay, electrical contact here. Now transistors are connected. Now what we will do, we will try to connect the B transistor. Okay, B. Okay, B input. Okay, how to connect? You see, for suppose this is my polysilicon. Okay, now what I need to take care is, whenever we are crossing the lines, between the colors, like, so we have already some rules, right? So you need to take care that the polysilicon of B input should not touch the polysilicon of A input. Okay, what happens if it touches? If it touches, in the previous part 1 we have already seen, there is a rule. What is the rule? The rule is, like, if two or more colors touch each other, then that is an electrical contact. Okay, so we need to take care that the polysilicon red is not crossing the red. Okay, so directly what I can do, I can take a red from here, from blue, and I will take it from blue again, and I will connect it to B. Okay, so this is the stick diagram of the stick diagram. I can have a metal contact here, right? I can have a metal contact here, okay, with B here, and I will give a B input here, and I shall take the V out from here, correct? So this is the stick diagram, okay, by using color codes. See, there is no specific rule that my polysilicon red should cross from here only, should cross from like this path only. Okay, I can also connect simply from here as well. I can also connect from here also. B should be connected to B. Okay, and while I am crossing, like, even my red is crossing metal blue, it is not an electrical contact, as well as it is not an transistor as well. So I can cross that. Okay, so that is the concept, okay, of the stick diagram and the implementation of the NAND gate, okay, using stick diagram. Next we'll see implementation of the stick diagram for NOR gate. Okay, for a NOR gate. So what is a NOR gate? My PMOS transistors are connected in series, NMOS transistors are connected in parallel. Okay, this is ground, this is ground. Okay, or else you can directly connect this thing, and this is ground. Okay, so this is A, B, and B, and I take my V out from here. Okay, now you see, the first step is to have VDD and VSS, correct? Now I will implement the PMOS transistors. The PMOS transistors you see here, which are in series. I have the P diffusion, polysilicon crossing here. Okay, so two PMOS transistors, and for NMOS transistors, two NMOS transistors are in parallel. Okay, so N diffusion crossing the poly is this thing. Okay, now we will establish the connections, right? So what we will do? So this is metal, right? Because I have used metal now, I will be establishing the electrical contacts, okay, here as well. Okay, next, now you try to give the inputs. So this is polysilicon, so I can use metal, or I can connect through red also. If I am directly connecting through red, and by using a metal, I can give this thing. This is also correct, but more amount of polysilicon we are using, that is not suggested. Okay, so that is also correct only, that is also okay, right? So, and here let us say for A input I have given the polysilicon. I will try to give the metal here, okay, for B input. So this is metal and metal. Okay, you establish the electrical contact. Okay, and this is my B input. Okay, so where is my output? The output is here. This is my output. So this is the stick diagram for a NOR gate. Okay, hope you understood. Now we will take another example. Okay, we will try to implement a stick diagram for the Boolean function f is equals to a plus bc whole bar. Okay, A plus BC whole bar. How you will represent this A plus BC whole bar using CMOS logic family? See here, by using AND or invert logic. Okay, first AOI logic. First you see here, what we will do, first we will try to take the BC. Okay, BC means the PMOS transistors are in parallel, okay, and NMOS transistors are in series. Okay, this is my demarcation line. Okay, this is BC. Now you see here I have an OR gate plus. For plus means the PMOS transistor of A is in series with the PMOS transistor of BC. That means I have a here. Okay, this is VDD, and the PMOS transistor of A is in series with the PMOS transistor of BC, right? Similarly, when it is series, here my NMOS transistor A will be in parallel. Okay, once you draw this, now you see NMOS of A is in parallel with BC. Now you give the connections. Okay, this is ground, this is my V out. Okay, ABC. I hope you understood this, how to draw this circuit diagram. Now we will try to draw this stick diagram. Okay, it is also easy. You see here I have VDD. So once you know how to draw the circuit diagram, it is by applying the color codes you can draw this one. Okay, so this is my VDD and VSS. First of all, I will come from the top. So I have 3 PMOS transistors to be established, right? So I will take the brown, and one is brown here, brown crossing red here, and again I will take brown and brown, red crossing. So 3 PMOS transistors are over. Similarly, I will take green here. So 2 transistors B and C, 2 NMOS transistors here, and one is for A. One is for A. Okay, so this is my A. Okay, so A, B, C, and A. Okay, now transistors we have established. Now we will try to establish the connections. Okay, so you see here I need to have an electrical connection here, electrical connection here, electrical connection here. Okay, so after this you see here, first there can be electrical connection. Okay, here I need to connect through a metal. These are in series, these are in series. Okay, again I forgot to draw this demarcation line. You draw the demarcation line as well. Now I took the metal and I have connected this thing, and I will be establishing the electrical contacts between brown and blue. Okay, and later on you see here, this is again you connect these things, you connect it here, you connect it here with the metal. Now you establish the electrical contacts here, here, and here as well as here. Okay, so and you take the V out from here. I hope everything is clear now. And now we will connect A with A and B with B and C with C. So because the distance is less, I will connect it through polysilicon for B, and I will have a metal here, such that this is nothing but B input. Clear? And for A, let us try to take it from inside. Okay, so what happens if I take it from inside? For suppose if I am taking the C color code with blue, let us say if I take it with blue, then I already have, let us say if I take it with this blue, then this is not a correct design, because blue is crossing with V out of blue. Okay, that means that is an electrical contact that should not happen, right? So what we do is what we do is we'll try to take it with polysilicon, or you take it other colors. Okay, and so what I will do, I will try to take it with the polysilicon only, because polysilicon crossing a blue doesn't make any difference. Okay, it is not an electrical contact, so I can connect this thing. Now A with A also I can take it from here. This is blue connecting A, and you establish the contact here, you establish the contact here, and you tell it as A. Okay, so this is the stick diagram for the Boolean function f is equals to a plus bc whole bar. So I hope the concept is clear. Now you will be able to draw the stick diagrams for any Boolean function. So if you are able to draw the circuit diagram using CMOS logic family, then you will be able to draw any stick diagram, okay, by applying these simple rules. Okay, hope you understood the concept, and if you like the video, please share and subscribe, share it with your friends and subscribe the channel. Thank you for watching. Thank you.